Problem number 13. What is the greatest 4-digit number which when divided by 10, 15, 21 and 28 leaves the remainder 4, 9, 15 and 22 respectively. So 4-digit number that has to be divisible by 10, 15, 21 and 28. So till now what we did means the greatest number which is going to divide means we have identified the divisor. But here the greatest 4-digit number which when divided by 10 means the number is going to be divided by 10, 15 and 21 means we have to calculate the dividend. Dividend is nothing but the multiple we have to calculate. So the 4-digit number we have to calculate. So calculate the LCM for 10, 15, 21 and 28. So multiple is nothing but LCM you calculate. So 10, 15, 21 and 28. So here I am considering 5. So 5 2s are 10, 5 3s are 15. So 21 as it is you write and 28 as it is you write. Next I am considering 2. 2 1s are 2, 3 as it is you write, 21 as it is you write, 2 14s are 28, 14 as it is you write. Next 3. 3 1s are 3, 3 7s are 21, 14 as it is you write. Next 7. 1 times 7 1s are 7, 7 2s are 14. So LCM will be 5 into 2 into 3 into 7 into 2. So 5 into 2 10, 7 3s are 21 into 2 42, 42 into 10 420. So the LCM is 420. So now we have to check which is the greatest 4-digit number. So greatest 4-digit number is 9999. Sorry, 9999. Yes, 9999 is the greatest 4-digit number. But this is not going to be divisible by 10, 15, 21 and 28 by leaving the remainder 4, 9, 15 and 22. So you divide this 999 by 420. You divide this 999 by 420. So 420 how many times? 420 2s are 840. 840. So what is the remainder? 159. Next 9 you write here. 4 4s are 16. So 4 times if you do it is more than 1599. So you have to do 3 times, 23 times, 3 zeros are 0, 3 2s are 6, 3 4s are 12. So what is the remainder? 9 3 3. So 339 is the remainder. So if you subtract 399 then it is divisible by 420 exactly. So 399 9999 minus 339 if you do then you will get 0669. So 9660 is the number which is exactly divisible by 10, 15, 21 and 28. So 9660 is the number which is going to be divisible exactly by 10, 15, 21 and 28. But I have to check a number or I have to identify a number which when divided by 10, 15, 21 and 28 it should leave the remainder of 4, 9, 15 and 22. 4, 9, 15 and 22. So you observe here 10 is the number which has to be used to divide. So when it is used to divide you are going to get a remainder of 4. So 10 minus 4 6. So you consider the next number 15. So 15 minus 9 if you do you will get 6. Next 21. 21 minus 15 if you do you will get 6. Next 28. 28 minus 22 if you do you will get 6. So the 6 is the common number which you are getting. So the number will be 9660 minus 6. So it will be 9654. So the number will be 9654. Option A is the right answer, 9654. So let me repeat. So you calculate the LCM of the given numbers. The LCM is 420. Next, the highest 4-digit number is 9999. So once you divide 420, sorry, once you divide 4 nines by 420, you are going to get a remainder of 339. Means if you subtract 399 from the number, then you are going to get a number which is exactly divisible by 10, 15, 21 and 28. So 9660 is the number which is going to be exactly divisible by all those 4 numbers. But once you divide, you should get a remainder of 4, 9, 15 and 22. So 10 minus 4, 6, 15 minus 9, 6, 21 minus 15, 6, 28 minus 22, 6. So we are getting a common number called 6. So if you subtract 6, then we will get a number which leaves the respective reminders such as 4, 9, 15 and 22. So the answer is 9654, option A. Let us go to the next problem, problem number 14. What is the smallest possible length that can be exactly measured by the scales of length 3 centimeter, 5 centimeter and 10 centimeter? It is nothing but LCM. So the length of the pole should be divisible by 3, the length of the pole should be divisible by 5 and the length of the pole should be divisible by 10. In the question, they are mentioning that the length of the pole should be smallest. The length of the pole should be smallest, means least multiple you have to check. Least multiple is nothing but LCM. So the LCM of 3, 5 and 10. So the numbers are very simple. Go for the different approach. 5 and 10. You consider 5 and 10. So which is the bigger number? 10. Is 10 divisible by 5? Yes. Therefore, for 5 and 10, 10 is the LCM. Now you consider 3 and 10. So is 10 divisible by 3? No. So go for the next multiple, 20. So is 20 divisible by 3? No. Next go for the next multiple, 30. Is 30 divisible by 3? Yes. 30 is divisible by 3. Therefore, 30 is the smallest possible length that can be exactly measured by the scales of lengths 3 centimeter, 5 centimeter and 10 centimeter. So for problem number 14, 30 centimeter is the right answer. Let us go to the next problem, problem number 15. The capacities of two pots are 240 liters and 112 liters respectively. Find the capacity of a container which can exactly measure the contents of the two pots. So you have to identify the capacity of a container. For example, consider you have two containers. So the two containers or the two capacities of the two pots will be 10 liters and 15 liters. 10 liters and 15 liters. So you should get a container in such a way that it should exactly measures the capacity of the two pots. See here, the 10 liters is the capacity of the one pot. So the HCF of 10 and 15 is 5. So 5 liters can, it is going to exactly measure 10 liters. So 5 twos are 10. So 2 times you have to use that can. 15 liters, it is exactly divisible by 5, 5 threes are 15. So 3 times you have to use that can to measure the second pot capacity. Instead of 5, if you use 4, so 4 twos are 8, 2 is the remainder. Still 2 liters is going to remain in the pot. So it is not exactly divisible by 4, therefore that is not the actual container what you have to take. So here you have to consider the HCF. So for 240 liters and 112 liters, you consider the HCF, which will be the capacity of a container exactly measures the contents of the two pots. Okay, so 240 and 112. So 240 is the greater number, 112 is the lesser number. You divide 240 by 112. So 2s are 224. So the remainder is 10 minus 4, 6, 3 minus 2, 1, 16. 16 5s are 80, 16 6s are 96, 16 7s are, how much 16 7s are? 112. 16 7s are 112. So the HCF is 16 liters. But in the option they have given in the terms of cc, cubic centimeter. So 1 liter is equal to 1000 cc. Therefore 16 liters is equal to 16 into 1000, which is equal to 16,000 cc. 16,000 cc is the answer. Option C is the right answer for the question 15. So 240 liters, 112 liters. So the capacity of the container should exactly measure the contents of the two pots, means it has to divide both the numbers properly and it should be the greater number. It should be the greater number. So the greater number which should divide 240 and 112 means you have to identify the HCF. So here the HCF is 16 liters, which is nothing but 16 into 1000, 16,000 cc. Let us go to the next problem, problem number 16. An electronic device make a beep after 30 seconds. Another device makes a beep after 31 seconds. They beep together at 10 p.m. What is the next time when they would beep together at the earliest? So it is nothing but LCM. So in the next time it should beep together means a time. For example, you take a simple number 10 seconds and 20 seconds. Now it has beeped. After 10 seconds A will beep, after 20 seconds B will beep. For example, 20 seconds, after 20 seconds means A will beep for twice and B will beep for once. So after 20 seconds both will beep together. See, 20 seconds, 10 twos are 20. Okay, for first 10 seconds A will beep once and for the second 10 seconds A will beep once. So at 20 second A will beep and at 20 second B will beep. So 20 is the LCM for 10 and 20. So here also you have to calculate the LCM for 30 and 31. 30 and 31. 31 is the prime number. So directly you can do. Otherwise you go with this method. 3 tens are 30, 31. So 10 ones are 10, 31. So which is nothing but 30 into 31. So in the previous problem itself I had told, okay, if both the numbers are co-primes then directly you can multiply to get the LCM. Here 30 and 31 both are co-primes because 31 is a prime number and 30 is not a prime number and the HCF between 30 and 31 is 1. So 30 into 31 you calculate, 31 zeros are 0, 31 threes are 93. So after 930 seconds it is going to beep again. But they are asking in the terms of minutes and seconds. So 930 seconds, so if you want to check in a minute means 930 divided by 60. 930 divided by 60. So 0, 0 cancel. So 6 15s are, 15 6 are 90. So 15 6 are 90 means after 15 minutes, okay, after 15 minutes, see 15 into 6. 90, 900. So still 30 seconds are remaining. So after 15 minutes and 30 seconds it is going to beep again. So after, see, 15 minutes and 30 seconds after 10 p.m. So after 15 minutes and 30 seconds it is going to beep again. Therefore option A is the right answer. So here it is very simple. You have to take the LCM for 30 and 31 and you calculate the LCM. So 930 seconds. So after 930 seconds it is beeping again, but you want to check in minutes. So 930 if you divide it by 60, because 1 minute it is having 60 seconds. So you are going to get 15 minutes. Still you are going to get some seconds as the remainder. So 15 into 6, 90, so 900 seconds. So still 30 seconds are remaining. So after 15 minutes and 30 seconds it is going to beep again. Let us go to the next problem. Problem number 17. So come to problem number 17. 6 bells commence tolling together and toll of intervals are 2, 4, 6, 8, 10 and 12 seconds respectively. In 1 hour, how many times do they toll together? Means how many times do they toll together? It is nothing but LCM. One time is there, at that time all the tolling, all the 6 bells are going to toll together. Okay, so 2, 4, 6, 8, 10 and 12, you have to calculate the LCM. So 2, 4, 6, 8, 10, 12. So 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6s are 12. Once again you divide it by 2. So 2 1s are 2, 3 as it is it will come, 2 2s are 4. So 5 as it is, it will come, 2 3s are 6. Next you divide this one by 3. So 1 as it is, it will come 1, 3 1s are 3, 2 as it is, it will come 5, 3 1s are 3. Now 2 and 5 are co-primes, so directly you multiply 2 into 3 into 2 into 5. So 5 2s are 10, 10 3s are 30, 30 2s are 60, 60 2s are 120. So 120 seconds. 120 seconds. So 120 seconds. After 120 seconds, they will toll together. Means 120 seconds means how many minutes? 120 by 60, which is equal to 2 minutes. Which is equal to 2 minutes. But in the question, they are asking in 1 hour, how many times do they toll together? In 1 hour, how many times do they toll together? So in 1 hour means 60 by 2, 30. 30 is not the answer. 60 minutes in 1 hour, 2 minutes once it is tolling, 60 by 2, 30. But 30 is not the answer. 30 plus 1, 31 is the answer. Because while calculating, okay, the first time it tolls together, that is the one time. Okay, in the first time itself it tolls together. After one time, again after 2 minutes it is going to toll. So in the first minute it is going to toll, after 2 minutes it is going to toll. So 60 by 2 means after 2 minutes, from after 2 minutes it is going to calculate. But for the first time when it tolls, that is the 1. The first time what it tolls, that is the 1, and after that 30 times it is going to toll. Therefore 31 times it is going to toll. So here the answer is none of these. Option E, none of these.